Today we're taking a look at the Quiz 8 preview for our upcoming Algebra 2 quiz. And as you will notice up here at the top of your review, factoring is going to become kind of important, and I'm mixing and matching things here, so there's no escape from things. One thing I would make mention of that might be a good idea, and I've mentioned this before, when you're trying to think of your squareds, you need to know your squares probably safely up to 10 or up to 100. Your cubes, we need to safely know up to 5. So when I look at a problem like number 1, I don't just say, oh, square root, I'm done. Remember, when I'm doing with squares, I can only do differences, only can do minuses. So here, with my shorty, and again, we've had the descriptions on the note sheets, we've had the descriptions on, side sheets we've done. Here's our main 2 sections that we've been doing. Even though we've gotten a little factoring in, you may have to go back and look at notes and keep practicing. Some of you have even mentioned to me, well, I need to come in and learn how to, no, this is mental math sense, that at a point where you've got to just work at them and keep playing with them. So what do I square to get each of these? Because the squared gives me a hint. I square 3 to get 9. Got to have the x on those. And I square 10 to get 100. I need to multiply to a negative, 1 of each. No solve, I'm done. But again, when I'm doing these, what else do I need to do? Some of you would immediately go and slide and divide on this. You don't need to. Use the golden rule. What divides into all 3 of these? That's right, 4 does. And if you're not sure, well, you may need to play with the calculator a little. So whatever I multiply 4 by to get each of these back, or some of you have said, well, can't I just divide 4 into each of these and that'll get me the answer? It absolutely would. 4 goes into 64 16 times. And now look, just by taking that 4 out, now I just have to do a diamond. I don't have to do slide and divide or any of that other fancy stuff. So I need 2 numbers that multiply to negative 16 and add to negative 6. Now again, before I even start thinking about numbers, I have some clues here that I can use. My product is going to be a negative. So one's positive and one's negative. I also know that since when I add them up, I'm going to get a negative answer, my negative number is going to be bigger. So those things are going to help me not mess up some of the details of this. So 16, I start going, okay, 4 and 4, 8 and 2. Ooh, 8 and 2. I can make this work. Bigger number's got to be negative. Okay? Use some of those clues to make it simpler once you start getting the numbers. But again, you've got to work at it. You don't just get good at this overnight. It's practice over a long period of time. Cubes. That gives me a clue. Both perfect cubes. I cube x to get x cubed. I cube 3 to get 27. And then this is the one where I have to know the pattern. There's no other way around it. X and 3, use the sign in the middle for my first set. And then remember our pattern. Square my first term. Change the sign. Take the product of those. And square my last term. And that's it. Cool thing about cubes, they never break down again. What you get is what you get. But again, you've got to know your form. Back on your note sheet, if you need to look it up, it looks just like this. And that's the pattern that I'm looking for. So I look down. Do these 2 have anything in common? No. Ooh, squareds. Oh, squared. Okay. What do I square to get x squared? X. What do I square to get 64? 8, and it's got a y. Oh, and plus minus. All right. Again, they're either going to come really quick or you're just going to sit there and stare at them. Hopefully I'm not going to have you being where you're going to just be staring at them. Now some of you panic when you see one like 5. You're like, wait a minute. That says x to the 4th. I don't know how to do x to the 4th. Well, my question to you is, do you know how to do this one? You're like, it's not the same problem, but it's going to work the same way, so just work with me. what multiplies to negative 56 and adds to 1? Okay, multiplies to a negative, adds to a positive. Positive number is going to be bigger. What multiplies to 56? 7 and 8. Okay, bigger is the positive. Well, how'd that help me? Just had me do an extra problem. Because this is going to factor the same way, except x times x is x squared. You add your exponents. What times what gets me to 4? 2 times 2. And I'm done. See how I take something that's similar and make it work into what I'm doing? Again, that takes some thought process and some time, though. It's something you have to do in math. If you don't, you're just kind of, screwed. 4 terms, we always pair them off. What do these first two have in common? Well, 3 divides into both of them. Okay. Well, what about they both have an x? I agree. But when we're looking at variable terms, remember, you're looking for the one with the smallest exponent, and you're going to use all of that. So 3x squared. I already got the 3. To get from x squared to x to the third is x. 3 times negative 5 is negative 15, and I already have the x squared. And as we've talked about before, if I do this right, once I take my factor out, I should have this come back again. So let's see how this works. So we look at the next one. We're like, okay, I can take out a 4. But then I look at it, I'm like, well, wait. When I go to do this, 4 times negative x would be this. Well, that doesn't match. That's when we go, okay, a little adjustment. Let's try negative 4. Negative 4 I already got. That's x. Okay. Negative 4 times negative 5 is 20. Okay. And then to write my answer, because I can't just leave it, is taking my greatest common factors and one of what was left over. And I'm done. Lots of different options, lots of little twists. Again, hopefully you've done your practice from the book work and when we did the factoring practice, but I guess I'm going to see. If f of x equals 3x plus 5 over 4, find the inverse. Okay, f of x is y equals. And again, our steps are switch the x and y around. And now work on solving for y. So I got a couple of things to do here. That fraction's got to go. And whatever I do to one side has to be done to both. Now I'm still working on isolating my y. And then like we talked about in class when we did this, you can either make it one big fraction and just divide by 3, or some of you liked being able to do them individually. Either one's going to work. You can either have 4 over 3x minus 5 over 3, or if you just left it, 4x minus 5 over 3. Either one's fine. Either one is absolutely fine. Let's see here. Draw an example of a graph whose inverse is not a function. In other words, does not pass the horizontal line test. Let's see. Inverse is not a function. Cannot pass the horizontal line test. Because if I did this and did my horizontal line test, the inverse of this particular one is not going to be a function. And that's all I have to do. Anything that has more than one point, you could do the squiggle line like we had in the notes. This parabola is fine. But read carefully because you don't know. Tomorrow it may be whose inverse is a function, like we did in the notes, or it might be is not a function, like we're doing here. So read carefully. Now when we get to the back, we're going to do this like we did the other day. This is not going to be f times g. Okay. Actually, I'm going to scribble these. When we prove this, okay, first I'm going to prove that f of x is an inverse of g of x. So I'm going to split this up. change this. So I've got x equals negative 3y plus 6 minus my 6 over. If I get going too fast, ask somebody to pause me for a minute. And I notice this one's split up. So I'm going to divide each individual term by negative 3. So let's see. Y equals negative 1/3 x, negative 6, and negative 3 is positive 2. Okay, check. It equals g of x. Here's what I want you to do, though. I want you to see that it works both ways. So if I start with g of x and switch those up, and then solve it for y like I was doing this other one, and multiply by negative 3, and distribute it through, that one also checks out. Okay, I want to see both. I want to see that this turns into this, and that this vice versa turns back into this. That's what we're on the lookout for here. And then the rest of this, for the most part, is review stuff. Here, I'm going to keep saying this, that's a minus. That is not a multiply. You do not do the box. You do not do distributing. You do not do anything. The only thing you distribute is that negative through to all of these terms. Personally, I would rewrite this one, changing all of my signs. And then I just combine like terms. I only have one cubic. Negative 6 plus 8 is 2. Don't mess with those exponents anymore. Only one x term. Negative 11. Negative 11 is negative 22. Again, watch the sign in the middle. If it's plus or minus, just combine like terms. Now if it says cubic, again, you have options here. Yes, I'm actually going to show you both. Okay. If you go with the pattern, if you played with Pascal a little bit before, and you remember the 1, 3, 3, 1, you can get by just doing 1 times my first term cubed plus 3, my first term squared, times my second, plus 3, my first term times my second term squared, plus my last term cubed. And this is going to go a lot faster than I'm about to do, but this gives you an option for both. 3 times negative 4 is negative 12. Negative 4 quantity squared in parentheses is 16. Times 3 is 48x. Negative 4 cubed is negative 64. What's my other option? Can I just do to the third and say x cubed minus 64? No. If you're going to write it out, if you didn't mess with understanding your form, what you're going to have to do is like we did before. Take them in pieces. Fill up your box. And then what I'm going to do is once I get my like terms together from my box, or if you FOIL, I'm going to make one more box with that last x minus 4 and get it in. And once I get this together, then I'll be done. You notice how much quicker this would have been if we'd have just had that form down from good old Pascal. And now, amazing, same answer. So whether you know your form or you do it, FOIL the first two and then distribute to the third, either one gets you the right answer. That's what's important. So whatever one works, that's what we're going to do. Now to the problem from last quiz, which we're not going to have happen again here. All right, we're having a bake sale to build a tree house. The revenue from the sale of pies is given by 10x. In other words, we're charging $10 a piece for pies that we're going to get in our pocket. Suppose the function for the cost of making x pies is p of x equals this. So in other words, this is telling me it costs $4.50 per pie plus $15 for something. Supplies, dough, I don't know. What are the pies selling for? It is not a tree house. It is not a bake sale. They are selling for $10. That is the only answer that works here. Okay. The profit function. Profit, we said before. Revenue minus cost. My revenue is 10x. I get $10 for every one. Minus my cost. Notice again, parentheses. I'm not just minusing the 4.5. It's also the 15. So 10x minus 4.5, and I'm actually going to write this out. And I've got like terms that I can combine. This is my profit function. Find the profit on 50 pies. As long as I did the profit function right, I can pretty easily find out how much money I made on 50 pies just by plugging the 50 in where the x goes. So again, it's up to you. When we come down here, let me stress something else from the last quiz. This x out here is just a label to tell you there's not a number to plug in. I'm doing f of x plus g of x. That's what it's telling me. I'm not multiplying x at the end. And a lot of you did that. We're not doing that here. I'm just going to take f of x plus g of x. And that plus just means combine like terms. And I'm done. You FOIL, if you multiply it through by an x again now, it's wrong. So please, please, please be careful there. F times g of x, again, just means f of x times g of x. A lot of you, since you've become fans of the box, I'll use the box. Doesn't matter which terms go on which side, as long as all of them get covered. And when I'm filling the box, I'm multiplying to fill the box. And little things like exponents, I have to watch out for. So I get here to the end, I'm like, ooh, none of them are alike. Okay, well, I'll just recopy what I see then. I get my answer. But again, notice I didn't do anything with that extra x. It's just there as a label. Okay, I'm changing 15 on the fly. This is becoming minus. So x squared minus 1 minus x plus 3. Distribute your negative. Do not just put it on the x. Grr. Find what's alike. Happy camper. And then finally, and you'll notice I haven't mentioned anything about the domain yet on 13, 14, or 15. And the reason for that is there's two times we read about the domain, you remember? Even roots, haven't had any roots, and fractions. Oh, fractions. Can I cancel these x's? Nope. Could I factor this out? Yes, but I'm not going to cancel anything with it. So if you just circle it, that's fine. If you did x plus 1, x minus 1, give yourself a pat on the back, and you're still right. But I have a fraction. What cannot happen in dividing with fractions? You can't have a 0 in the denominator. Oopsie. So x plus 3 under no circumstances can equal 0, but I need to know the value. So I'll subtract the 3 over. Okay, x cannot equal 3, but how do we write that? This is how we write. We want every single number except -3. But you have to do something with the domain. If you don't, you're missing points. And again, we can't afford to lose all these halves everywhere just because we don't feel like reading the whole problem. So again, be careful. Okay. Multiplying on these next two. Notice now there's a number here instead of x. That literally means that number goes in where the x goes. So I want to know what p of 7 times q of 7 equals. Plug 7 in. 2 times 7 is 14, plus 3 is 17. The absolute value of 17 is still 17. Plug 7 in for x. 2 times 7 is 14. 4 minus 14 is -10. Multiply them together. Okay? I don't have to try and combine them and then figure out the absolute value. Just plug the numbers in. Do the same thing here. All I want is q of -2 and p of -2. Okay, 2 times -2 is -4. -4 plus 3 is -1, but its absolute value, it's 1. 4 minus 2x, -2 times -2 is 4. 4 plus 4 is 8. Okay, multiply them together, I'm done. When it comes to my sketch. Now, would I personally at this point hope that we could look at one of these and say, okay, that plus 5 means I'm going up 5. Negative means it's opening down, and I just start plugging some numbers in. Okay, 1. 1 squared is 1. -1 plus 5 is 4, and I know it's symmetrical. Okay. 2. 2 squared is 4. -4 plus 5 is 1. Now, if what I just did like blew your mind, okay, here's our backup plan. Bring this up, I'm going to clear these out. I'm going to type this in my graphing calculator. I am going to go to my table. I'm going to see the symmetry, and I'm going to find the same points that I just made on here, just using some quick mental math, and jot those points down and draw my parabola. So now that I have this picture, my domain, that hasn't changed in like forever, -infinity to infinity, because it goes forever out to the left and right. Now my range, be careful, bottom to top. What's the bottom value of my range? -infinity. Where's the top though? Right there at 5. If it turns and they're both going the same direction, your range is not going to be, -infinity to infinity. End behavior. One's always going to be negative, one's going to be positive infinity for x. Remember, here's positive infinity, here's negative infinity for x, positive and negative infinity for y, and let's just follow along. As x heads towards negative infinity, as it heads to the left, what's happening to y? It's going down towards negative infinity. Is my graph's heading towards positive infinity to the right? It's heading to negative again. Now I'm going to say the same thing that I've said throughout the last 3 quizzes on these. Some of you, you're starting to pay attention to this. If there are parts of this that the only reason you got them right is because I was talking you through and making you write everything, those are the things you need to go back and look at again. Notice I didn't put the sections on this time. This is 6-3, 7-3 in review. If you have thrown away quizzes, if you have thrown away notes, I don't know what to tell you. I guess you're going to need to go back to the website. The website, remember? The website. This thing right here, where you go to Algebra 2 over here, you click on this week. Blank previews, if you need to go through and do this again on your own now that you've watched it. The key, if you want to look at certain answers when you've done certain things on your own. In the video, there's going to be a link right here when you're actually looking for it. But if you're not understanding other stuff, go back to some of the last few weeks. Look at all the weeks of material that's here. Find what you're struggling with and work on it. That's the only way it's going to get better. Telling me I don't know is not going to make it better. Okay, I'm going to be done with the lecture now because I got to get some other things situated here. But good luck and do a good job, and hopefully I'll see the fruits of your labor on Wednesday.